This program, FIRFILT, shows how the spectra of sounds are affected by FIR filters. You start by selecting the type of FIR filter in this window here, and a variety are available. Let's choose a Kaiser filter. We can select the length here, and for filters like the Kaiser filter which have additional parameters, they will show up down here. We can select low pass, high pass, band pass, or band stop filters. For the low pass, there's one parameter to be adjusted, which is the corner frequency. And over here on the left panel, you can see the impulse response that results. You can also change the value of the corner frequency here. Now let's go ahead and get a sound. The middle panel here shows the spectrogram of the input sound, which you can play here.
She sells seashells.
And the lower panel shows the output of that sound filtered.
She sells seashells.
As you change the bandwidth of the filter up here, you can see that the spectrogram of the filtered output changes as well.
She sells seashells.
When you load a sound, a second frequency axis shows here, which shows the mapping between discrete time frequency of 0 to pi and the analog frequency of 0 to 1/2 the sample rate, in this case about 5500 Hz. In each spectrogram, there's a small, semi-transparent block cursor bounded by two red lines, and you can move that block cursor by dragging in the middle. The piece of the time waveform that corresponds to the width of this cursor is shown in the left-hand panel here. This is the input, and this is the corresponding part of the filtered output. We can play just those parts by clicking this button here and mousing in the appropriate axis. That demonstrates the big effect that this low-pass filter has on a consonant such as sh from she. We can also move the time window with this slider here. And you can change the size of the time window either by moving this slider here or by directly manipulating one of the boundaries of the window here. So for example, here you can show that this particular filter doesn't affect the vowel as much as it does the consonant. This program is one of a suite of programs that I have developed to explain DSP concepts to my students during lectures. There are now well over 24 programs covering many aspects of the material in the book, including complex exponentials and sinusoids, convolution, the DTFT, pole zero plots and their relation to frequency and impulse response, A to D and D to A conversion, including upsampling, downsampling, resampling, and aliasing, the design of many types of FIR filters and their application to the filtering of speech and other signals, the design of IIR filters, circular shift and convolution using the DFT, the discrete cosine transform, and the short-time Fourier transform. A selection of these programs is being made available to instructors who are currently adopting the book in their classrooms. For further information, please visit cambridge.org/Holton.